Deep Ocean Survival Protocol. Viperfish Encounter Documentation Clearance Level. Sigma 7 restricted. This briefing addresses Protocol 9 Foxtrot. Vertical Migration Response Procedures. Chauliodus macouni encounters at depth. Personnel operating between 600 and 4500 meter are advised. You will encounter them. The question is not if. The question is whether you recognize the signs before impalement occurs. Section 1. Baseline Threat Assessment. Pacific Viperfish, Sloan's Viperfish, Chauliodus macouni. Body length, 30 to 60 centimeters. Fang length, 5 to 7 centimeters. The largest tooth-to-body ratio of any fish on Earth. Teeth so large they cannot fit inside the mouth. They curve backward over the skull. They rest against the eyes. Special sockets in the cranium accommodate fang tips when jaws close. If a tooth breaks during strike penetration, it continues through skull cavity. The viperfish pierces its own brain. Death occurs in 4 to 7 minutes. Jaw muscles remain contracted throughout. You are advised to understand. This creature evolved teeth so lethal they can kill the predator itself. It attacks anyway. Section 2. Biomechanical function. Lower jaw articulation, 90 degrees or greater. Jaw can dislocate to accommodate prey, twice viperfish body mass. Strike acceleration, 0 to 40 kilometers per hour in seconds. Hunting methodology differs from conventional predation. Viperfish do not bite. They impale. Standard hunting posture, motionless suspension, jaws open 90 degrees. Photophores activated along body in precise rows. 350 light producing organs per specimen. Light patterns pulse in synchronized sequences. Prey approaches light source. Viperfish accelerates forward. Fangs penetrate target. Backward-facing serrations prevent extraction. Post-strike behavior. Violent lateral shaking to tear tissue. If prey too large to swallow, viperfish maintains impalement for extended duration. Digestive enzymes leak from mouth cavity. External digestion occurs while prey remains alive. Personnel should note, stomach distension capacity reaches 200% normal volume. Vertebrae compress to allow passage of oversized prey through body cavity. The viperfish is biomechanically optimized for consuming targets larger than itself. Consider implications for human-scale encounters. Section 3. Incident Report 3A07. Trawl net exposure, 1994, deep-sea trawl operation, 1800 meter. Pacific Ocean, eastern approach to Mariana Trench. Net retrieval contained 200+ viperfish specimens. Standard protocol, immediate specimen freezing. Crew proceeded with catch sorting. 8 personnel on deck. Surface exposure duration, 40 minutes. At 0723 local time, multiple crew members vocalized distress simultaneously. 17 viperfish had leapt from sorting table. Despite 40 minutes atmospheric pressure exposure. Despite surface temperature differential. Despite complete environmental unsuitability for survival. They were still hunting. 2 crew members sustained fang penetration. Fangs pierced through rubber safety gloves. Through palm tissue. Exit wounds visible on dorsal hand surface. Medical officers report notes. Teeth remained embedded when victims brought to sick bay. Manual extraction required pliers. Teeth possessed backward-facing serrations not documented in prior literature. 1 tooth fragment could not be removed without surgical intervention. Fragment lodged in metacarpal bone. Victim reported, "Tooth kept moving inside my hand for 3 days after incident." Analysis determined residual electrical signals in tooth tissue. Muscle contractions continued post-mortem. Most significant observation: puncture wounds emitted faint luminescence for 6 weeks following exposure. Bioluminescent bacteria from Viperfish oral cavity had colonized wound tissue. Bacterial culture resisted standard antibiotic treatment. Victims glowed in darkness. Consider the evolutionary purpose of this bacterial transfer. Prey that escapes initial strike becomes marked. Luminescent signature visible to predators. Prey is tracked indefinitely. Section 4. Vertical migration patterns. Viperfish execute diurnal vertical migration. Daytime depth 2000 to 4500 meter. Nighttime depth 600 to 800 meter. Vertical displacement 1000 meter or greater. Every night, without exception. This represents the largest animal migration on Earth by participating biomass. Billions of organisms ascending from abyssal darkness, following prey concentrations toward surface waters, rising from below you. Migration velocity 200 meter per hour. Silent ascent, relentless. If you remain stationary at 1500 meter during evening hours, migration passes through your position. You do not descend into Viperfish territory. They ascend into yours. Personnel are advised. First indication of migration is not visual. It is pressure wave detection. Thousands of bodies displacing water mass. Your inner ear registers approach before eyes confirm presence. Second indication, bioluminescence. Isolated points of light in darkness below. Then dozens. Then hundreds. By the time you observe lights, migration front has reached your depth. You are already surrounded. Section 5. The grid phenomenon classified observation log requires security clearance Sigma 4 or higher. Following data authorized for personnel in active deep zone operations. Since 2008, 6 documented incidents of geometric formation behavior. Viperfish arranging in precise grid patterns. Standard scientific literature classifies viperfish as solitary hunters. Individuals operate independently. No coordinated group behavior documented prior to 2008. Incident Report 7B. Manned submersible, 2400 meter mid-Atlantic ridge. Mission objective, geological sample collection from hydrothermal vent systems. At 1947 hours, pilot observed luminescent points surrounding vessel. Initial count 40 plus light sources. Distribution radius 10 meter. Lights arranged in perfect grid. Spacing 5 meter between each point. Equidistant. Precise. At 1952, grid began contracting. All lights moved inward simultaneously. Formation maintained during movement. Pilot initiated emergency ascent. Grid followed. Maintained 5 meter spacing throughout pursuit. At 2100 meter first impact against viewport. Audible crack. Then 4 additional strikes in rapid succession. Exterior illumination activated. Revealed, Viperfish swarm exceeding 100 individuals. They were using coordinated photophore patterns to herd prey. The prey was the submersible. Viewport examination showed scratches. Tooth marks in 3 centimeter thick acrylic. Material, rated for 6,000 psi external pressure. Viperfish did not flee from high-intensity lights. They circled, approached, retreated, approached closer. They were studying the submersible. Encounter duration 3-4 minutes. Swarm dispersed without apparent cause. Grid formation dissolved. Individuals departed in separate vectors. Post-dive inspection recovered scale fragment embedded in viewport scratch. DNA analysis confirmed Viperfish origin. Genetic marker unknown to reference database. Possible new species or deep genetic variant. Carbon dating from growth rings indicated specimen age 18 to 22 years. Further documentation on grid phenomenon classified. Clearance upgrade available through standard authorization protocols. Section 6. Neurological paradox. Viperfish brain mass, % of total body mass. Smallest brain-to-body ratio of any vertebrate predator. Yet documented behavior includes spatial awareness across 50-meter radius, synchronized group movement, geometric formation maintenance, coordinated tactical positioning, target assessment and approach modification. These behaviors require neural processing capacity beyond Viperfish biological architecture. 3 theoretical explanations exist. Theory 1. Emergent behavior from simple stimulus response patterns. Individual Viperfish follow basic rules. Complex group behavior emerges without coordination, similar to insect swarm mechanics. Theory 2. External coordination mechanism. Viperfish respond to environmental cues humans cannot detect. Electromagnetic fields, pressure gradients, chemical signals. Apparent intelligence is environmental response. Theory 3. They are significantly more intelligent than biological architecture suggests. Neural processing distributed throughout body. Decentralized cognition, or alternative processing substrate we do not recognize as brain tissue. Personnel should understand. We do not know which theory is correct. We do not know if Viperfish are following instinct or executing strategy. We only know they behave intelligently. Whether they are intelligent remains unconfirmed. Section 7. Incident Report 3A12, ROV Survey 2015, Unmanned Remotely Operated Vehicle Survey. Depth, 3800 meter Tonga Trench. Standard benthic mapping operation. Camera orientation, seafloor. At timestamp 04/13/07. Object entered frame from above. Viperfish, estimated length 4-5 centimeters. Descended into camera view. Positioned itself 20 centimeters from lens. Specimen remained motionless for 4-7 minutes. At 05:00:14, second Viperfish entered frame. Third, fourth, fifth. Final count 9 Viperfish. All hovering directly in front of camera. All facing lens. All with jaws open. Fangs visible. Formation arrangement 3 rows of 3. Perfect grid. At 05:47:22. All 9 specimens attacked simultaneously. Camera feed interrupted for seconds. When feed restored, Viperfish absent. ROV recovery showed 4-3 puncture marks on camera housing. Titanium alloy construction. Puncture depth 8 millimeters. Material analysis revealed twisting pattern in puncture geometry. Viperfish struck rotated heads, then withdrew. Behavior consistent with attempting to drill through housing. Engineering assessment concluded. If attack continued for 2 additional minutes, camera housing would have been breached. Most significant finding: puncture marks arranged in geometric pattern, not random distribution. Coordinated target points. Structural analysis identified puncture locations as maximum stress concentration zones. Optimal points for material failure. Question requiring investigation. How did they identify structural weak points in manufactured titanium housing? Section 8. Protocol 9 FOXTROT engagement procedures. Personnel encountering Viperfish activity must follow established response protocols. Rule 1. If you observe single point of light in darkness, you have already been observed. Viperfish lateral line detects pressure waves from 3 meter distance. Visual confirmation is final stage of approach sequence. Initial detection occurred minutes prior. Rule 2. If lights multiply, do not assume they are approaching. Additional visible photophores may indicate specimens were present but inactive. Activation of bioluminescence does not confirm movement. You may already be surrounded by dark state specimens. Rule 3. If lights arrange in geometric formation, do not attempt rapid ascent. Grid formation indicates coordinated hunting behavior. Rapid movement triggers strike response. Maintain position. Minimize activity. Wait for formation dispersal. Rule 4. If specimen approaches within 2 meters, do not activate high-intensity illumination. Viperfish do not flee from light. Sudden illumination may be interpreted as threat display. Defensive strike follows threat detection by seconds. Rule 5. If impact occurs against viewport or hull, inspect for puncture depth immediately. Viperfish fangs can penetrate 8 millimeters into titanium. Standard acrylic viewports, 3 centimeters thickness. Multiple strikes in same location compromise structural integrity. Rule 6. If Viperfish specimen remains motionless while observing you, assume assessment is occurring. Prolonged observation precedes coordinated group behavior. Individual specimen is transmitting information to nearby specimens. Method of transmission unknown. Rule 7. If lights retreat suddenly, do not interpret as successful deterrence. Retreat may indicate repositioning for improved strike angle. Maintain vigilance. Monitor all approach vectors. Rule 8. If fang penetration occurs to personnel, do not attempt immediate extraction. Backward-facing serrations cause tissue damage during removal. Extraction must be performed in controlled medical environment. Tooth fragments may remain embedded. Fragments continue muscular contractions for up to 72 hours post-incident. Rule 9. If wound exhibits luminescence, you have been marked. Bioluminescent bacteria colonization creates tracking signature. Signature visible to predators at depth. Bacterial infection resists standard antibiotic treatment. Expect luminescence duration of 4 to 8 weeks. Rule 10. If you are alone at depth during evening hours, you are not alone. Section 9. The column Incident Report 3A19-2019, Scientific Research Station Aquarius. Depth 800 meter. Night observation dive 2230 to 0030 hours. Peak Viperfish hunting period. Diver reported observing ribbon of light approximately 60 meter distant. Ribbon ascended slowly from darkness below. As distance decreased, ribbon resolved into column structure. Column composed entirely of viperfish. Estimated specimen count, 400 plus individuals. Column width, 4 meter. Column height, 30 meter or greater. Extended beyond visual range, above and below. All specimens swimming in synchronized vertical formation. Photophores pulsing in wave pattern. Light traveled from bottom of column to top in rhythmic sequence. Diver description recorded. Like a living tower of light rising from hell. Column passed within 8 meter of diver position. For 6 minutes, diver surrounded by wall of teeth and eyes. Radio transmission log, timestamp 2307. They're not looking at me, they're looking past me, at something behind me. Diver rotated to check rear position. Visual confirmation, nothing present. Open water, darkness, no contacts. When diver returned to forward orientation, column had stopped moving. All 400 plus viperfish now facing diver directly. All jaws open. Perfect stillness. Duration 11 seconds. Then column resumed vertical movement. Continued ascent. Diver no longer acknowledged. Diver initiated immediate surface return. Refused to complete scheduled dive. Post-incident psychological evaluation. No abnormalities detected. Diver simply stated, "I will not go back down there." Analysis of diver's description matches bait ball herding behavior. Large predator groups coordinate to concentrate prey into dense formations. Then attack formation from multiple vectors simultaneously. However, viperfish are documented as solitary hunters. Coordinated hunting in groups exceeding 10 individuals has never been observed. Group size of 400 plus is unprecedented. Theory: diver interrupted large-scale coordinated hunt in progress. Column's 1 second pause was threat assessment. Decision made, diver not target. Hunt continued. Question requiring investigation. What were 400 viperfish hunting that required coordinated column formation? What prey is large enough to justify that response? Section 10. Sound Analysis, Classified Observation 2021, Deep Sea Acoustic Monitoring Array. Depth, 2200 meter. Standard passive sonar operation. Array detected unidentified sound signature. Frequency 28 Hz. Below human hearing threshold. Pattern, pulse every seconds. Consistent rhythm. No variation detected across 6-hour monitoring period. Triangulation placed sound source in area where viperfish grid formation was previously observed. Sound classification unknown. Does not match any documented marine species. Does not match geological activity. Does not match human-generated noise. Closest known analog, echolocation. But viperfish do not use echolocation. No documented cases exist in scientific literature. 2 theories under investigation. Theory 1. Viperfish developed new communication method in recent evolutionary timeframe. Sound-based coordination replacing or supplementing visual signals. Would explain grid formation precision. Would explain coordinated tactical behavior. Theory 2. Viperfish have always produced this sound. We simply started listening in 2021. If Theory 2 is correct, implications are significant. Viperfish have possessed coordinated communication for entire evolutionary history. Millions of years. Hunting in organized formations since before human species existed. We only observed them hunting alone because we could only see individual specimens. We lacked instrumentation to detect group coordination occurring beyond visual range. The teeth may be ancient. The tactics may be older. Section 11. Survival probability analysis. Personnel survivability during viperfish encounter varies by response protocol adherence. Scenario 1. Single specimen passive observation. Survival rate 94%. Individual viperfish typically withdraw after initial assessment. Strike probability increases if personnel exhibit prey-like movement. Scenario 2. Multiple specimens, no formation behavior. Survival rate 87%. Increased strike probability due to competitive feeding response. Specimens may attack each other, reducing focus on personnel. Scenario 3. Grid formation, personnel stationary. Survival rate 73%. Grid indicates coordinated hunting. Stationary personnel may be assessed as non-prey. Movement during grid formation reduces survival rate to 41%. Scenario 4. Grid formation, personnel attempting rapid ascent. Survival rate 12%. Rapid movement triggers strike response across entire formation. Multiple simultaneous impacts overwhelm defensive measures. Scenario 5. Column formation encounter. Survival rate unknown. Single documented case. Personnel survived, but encounter parameters not replicable. Insufficient data for probability calculation. Scenario 6. Contact with viperfish during vertical migration. Survival rate variable. Migration involves thousands of specimens. Most pass without interaction. However, statistical probability ensures some specimens will investigate. Personnel should note survival statistics based on reported incidents only. Unreported encounters may alter probability calculations. Personnel who did not survive cannot file incident reports. True survival rate may be lower than documented figures suggest. Section 12. What they want. Final briefing section addresses operator question most frequently submitted. What do viperfish want? From biological perspective, food acquisition. Viperfish are predators. They hunt. They consume. Survival motivation is caloric intake. This explanation satisfied researchers until 2008. Grid formations are not optimal hunting strategy for individual caloric gain. Coordinated positioning requires energy expenditure. Maintaining 5-meter spacing during pursuit is metabolically expensive. Individual ambush predation requires less energy. Column formations are even less explainable. 400 viperfish moving in synchronized vertical migration. For what prey? What target justifies coordinating 400 individual predators? Alternative explanation: they are not hunting for food. They are hunting for information. Submersibles, ROVs divers, research equipment. These are novel stimuli in deep ocean environment. Viperfish may be investigating, testing, learning. The 4-7-minute observation period in ROV footage. The 3-4-minute submersible encounter. The 1-1-second pause during column formation. These are not feeding behaviors. These are assessment behaviors. Question requiring consideration. What are they assessing? Our structural integrity, our movement patterns, our response to stimuli. Whether we are threat, whether we are prey, whether we are something else. And when they complete their assessment, what conclusion do they reach? We do not know. They have not told us. They cannot tell us. Or perhaps they are telling us, and we lack instrumentation to understand the message. The 28 Hz signal pulses every seconds. We record it. We cannot decode it. Perhaps it is not meant for us. Perhaps it is instruction to other viperfish. Perhaps it is warning. Section 13, Closing Protocols. This concludes Incident Report 3A. Report 3B documents Mariana Trench anomalies. Report 3C addresses abyssal gigantism in predator species. Both reports require security clearance Sigma 7 or higher. Authorization protocols available through standard channels. Personnel are advised to maintain situational awareness during deep zone operations. Monitor for bioluminescent signatures. Observe formation patterns. Report geometric arrangements immediately. Remember Protocol 9 Foxtrot Primary Directive. If you see one light, there are 20 you do not see. If you see 20 lights, you are already surrounded. The deep ocean is not empty. It is occupied. And the occupants have been here far longer than we have. They know these waters. They know the darkness. They know what moves through it. End briefing.